microplastic released to the aquatic environment during mechanical recycling process, because recycling is a potential means of reducing plastic pollution. So in this study, water samples were collected in around the facility recycling electronic plastic waste, and the PET bottle waste, and the household plastic waste for microplastic measurement. So here are highlights of this study. So mechanical recycling without wastewater treatment was at least a source of microplastic. So effluent microplastics concentrations were very high as compared with data reported for surface water and wastewater treatment plants effluent sample or like this. So annual microplastic emission from facilities were comparable to total discharge from wastewater treatment plants in Denmark, all the wastewater treatment plants, I mean. So which means the amount of microplastic emission from recycling facility is very, very high. So with mechanical recycling likely to increase as we move to circular plastic economy, greater microplastic emission can be expected. So based on that, as the future works, we have to understand the scale of microplastic generation and the release from plastic mechanical recycling, as well as their environmental risk in the aquatic environment. Okay, third topic. So as mentioned in previous slides, so significant stocks of plastic have already accumulated in aquatic environment. So if accumulated plastics are likely to be continuously fragmented in the environment, the proportion of microplastic and nanoplastic to total marine plastic may continue to rise. So therefore, it is important to understand the fate and the behavior of microplastics to predict microplastic and nanoplastic generation in the environment. So therefore, as fate and the behavior in the environment, study on fate and the behavior of plastics in the environment has been conducted since April 2021 in communication with the Japan Plastic Industry Federation. So purpose of this study is to investigate the mechanism and the generation factors of microplastics due to plastic degradation in the environment. Here are highlights of these studies. So internal structural change of plastic litter collected in Japanese beaches, as shown here, were characterized using the same EDS, suggesting that degradation tendency vary by polymer type, as shown here. So, for example, so polypropylene is easy to be decomposed, but PVC is very tough against degradation. So furthermore, FTIR and GCQ mass measurement of microplastic collected in Japanese beaches revealed that polyethylene and polypropylene having phthalates and antioxidants tend to be detected. Based on outcomes obtained in field investigation, we have been conducted accelerated UV testing and outdoor weathering test for understanding mechanism of plastic degradation leading to microplastic generation. In future works, we try to provide the mechanism and generation factors of microplastic due to plastic degradation in the environment. So it must be useful to improve emission inventory of plastic waste for subsequent air control, because current emission inventory provided by many organizations cannot include emission factor of related with generation factor about plastic decomposition. So one more important research towards understanding nanoplastic. We prepared a nanoscale particle of 5 major polymer, such as polyethylene, polypropylene, PVC, and polystyrene as potential standards for the study of nanoplastic. So by using these particles, we will conduct quantification of the concentration of nanoplastic in environment in the future. And also we try to use these particles for ecotoxicological test because our product does not contain any additives. So it's, I mean, the very, very pure plastic. So we can see the simple effect derived from plastic, non-plastic. Okay, let me summarize my presentation. So in Japan, MOEJ and the NIS have been tackling the marine plastic pollution under the Osaka Blue Ocean Vision. So MOEJ has conducted various efforts such as establishment of new law, development of guidelines, and the publication of preliminary inventory. So NIS has worked on the various researches to understand fate, behavior, and the effects of plastic, including microplastic, for proposal of methodologies to control plastic pollution. Okay, finally, so I really would like to thank to our collaborators and also organization giving us fund for research. Okay, thank you very much for your kind attention.
Thank you very much, Dr. Go Suzuki. Very interesting presentation regarding microplastic global pollution. Okay, now the time for QA sessions to all of the participants. Now you are allowed to unmute your microphone. If there is any question to Dr. Suzuki, please do not hesitate to raise your hand, please. Is there any questions? Nobody raise hand, I think. Okay. Okay, there's one question from Mr. Sambiring from BRIN to Dr. Suzuki.
Yeah.
Is there any medical consequence of microplastics? The question in the chat box.
Oh, okay, so this means the toxicological effect for human or a fish or something?
Yes, exactly.
Okay, I think there are so many evidence, but I think there is a big gaps between the lab experiments and the environment because mainly in lab experiments, researcher used nanoscale plastic and very, very tiny particle. But in the environment, we cannot investigate such a tiny microplastic.
Mm-hmm.
So now we are only measured, I think, more than at least 10 micrometer of microplastic, more than. So, but I mean that. So it's very, very difficult to do risk assessment. So, that's why we have to do many research to do precise risk assessment of microplastic, I think. Is that okay?
Okay. Is there any evidence about TDI value for microplastic, like a tolerable daily intake for human?
Sorry.
There's any TDI or tolerable daily intake value for microplastic to humans?
Yeah, I think up to now, so there is no TDI value of microplastic. So in Japan case, we have just started to discuss about this now. So we try to collect many differences for setting this value. So I think it takes a much long time to set a value, I think. Yeah.
Okay, thank you, Dr. Suzuki. There is a further questions from Ms. Nur Akmalia Hidayati, please.
Okay, thank you for the opportunity. Such a very interesting topics about microplastics. So I've read that one primary source of environmental microplastic, one of the sources for microplastic is the personal care and cosmetics products that containing microbeads. So if the microplastic is bad for environment and health, why is that? Is it a law in personal care or in cosmetics that they are still using the microbeads? Is there any regulation regarding the matter? So yeah, if it is harmful, why such companies like cosmetic or personal care or skincare are still allowed to use that kind of microbeads in their composition?
Yeah. So thank you very much for thank you very much for your question. So I asked a company person to respond to your question, but there is no company person here. So I will try to respond to your question. So I think some company person think microplastic has no effect against some living food. But some company person think microplastic do toxicological effect to living world. So I think many company try now stopped to use microbeads in their product. So in Japan, I think there are lots of company almost stopped to use this one. And in my understanding, so microbeads we cannot. It's their case to detect the microbeads in the environment. So other type of microplastic detected in the environment. So it's I think current situation. So but in the future, so company will stop to buy the such cosmetic including containing microbeads, I think. Okay.
Oh, okay. But the usage is still, microbead is still allowed until now, right? Because yeah, I like to use some of the scrub for my face.
You want to use.
So yeah, I feel guilty if the microbead is harmful for the environment. I'm gonna stop using that kind of stuff if it is harmful for the environment. So yeah, I think sometimes we still need that kind of personal cares, but yeah, maybe is there any, how to say, wastewater treatment to stop the microplastic leaking to the environment before, in the treatment. Is that is that can be a solution in this case?
Yeah, I think you are right. So we so that we have to do analysis about this kind of benefits. Current based on the current situation, so at least we have to do the wastewater treatment for removing such compound. I think.
Okay, thank you, Dr. Suzuki. Yeah. Okay, there's a question from Professor Suhendra. What policies and methodologies are appropriate for reducing plastic waste in Indonesia based on Japanese experience?
Sorry?
There is a question in chat box from Professor Suhendra. What policies and methodologies are appropriate for reducing plastic waste in Indonesia based on Japanese experience?
Okay, so it's a very difficult question because in Japan we also try to save the try to seek how to reduce the plastic pollution, so that we try to do emission inventory to set emission inventory with plastic. Uh, and then based on that, we try to set the measures to against the plastic pollution. So from now, we try to set the suitable measures, and then we can share such information to your countries. Okay, please be patient about that. Sorry.
Okay, thank you, Dr. Suzuki.
Yeah.
Next question, please, Ms. Wasmi. You're still mute.
Okay, thank you very much for your great presentation, Mr. Suzuki. I would like to have a question. Is there any method for treatment microplastic that is already found in the ocean or in the water body? That's my first question. And then the second one, I ever heard that microplastic has been found in also the breast milk. So do you think how this can happen actually? Is it coming to our food chains or something like that? Okay, thank you very much.
Yeah, thank you. So I couldn't catch first question. Could you please?
Is there any method for the treatment of microplastic that has been found in ocean on our river, for example? I think do you think like a filtration it will help, or do you have any other method that is much more effective to remove the microplastic from our water and ocean? Thank you.
Okay. Okay, thank you very much for your good question. So for first question, so I think the most important is to remove these tiny plastic in the wastewater at the wastewater treatment plants. It's I think easy to remove all these kind of compounds, and then so based on the research regarding plastic decomposition in the environment, so if plastic is easily to decompose in the environment, we have to remove microplastic from the river and the environment. But if plastic is tough against in the environment, in the future, we try to remove them. So I think it's really depending on the scientific evidence of the plastic. So, but I think it's easy to remove the plastic from wastewater at the beginning, I think. The second question, second question. Second question is very difficult for me because not only plastic but also other compounds detected in our body. So I think I don't know plastic directly affected to the human, or plastic contains chemicals and plastic some compound attached in the plastic. So there are so many situations for this issue. So for that, we scientists have to do research about this topic, I think. Okay. Thank you very much.
I think one last question for you from Ms. Ernie Sukocho. Is there any comparison between microplastic and heavy metals content in ocean in terms of consequences to health?
I don't have any comment about that because I don't know about the heavy metal in mining. So I'm
Okay.
sorry about that.
Okay, no problems. Okay, thank you, Dr. Suzuki.
Mhm.
I think that's last question from this QA sessions. Before moving to the next session, I will resume this session. I have some notes about Dr. Kosugi's summary presentation. Plastic usage has been a remarkable increase in the mid-20th century. Microplastic and microplastic are globally distributed in the sea surface and have become a global problem. Land-based mismanaged plastic waste made the main cause of the river pollution that end up in the oceans. Rivers of the Asian countries are identified as prominent contributors to the global ocean pollution. Packagings, consumer products, and textile accounted for around 60% of plastic waste. Around 22% of global plastic waste is disposed of into uncontrollable sites, burned in open pits, or leaked into the environment. There is a global initiative or commitment to reduce additional pollution by microplastic to zero by 2050. And finally, we also have a lesson learned from NICE Japan regarding 3 key research areas, namely monitoring and emission control of river plastic wastage, fate and behavior of plastic waste during recycling, fate and behavior of plastic waste in the environment. Okay, Dr. Suzuki, before we ending this session, please take a photo picture and receive our certificate as an appreciation to you as a keynote speaker for today's seminar.
Thank you very much.
Yeah. 1, 2, 3. Okay. Thank you.
Thank you very much.
Yeah, you're welcome. Okay, that's the end of our session. Please give big virtual applause to Dr. Go Suzuki. Now I deliver the floor back to MC Mas Rizky. Thank you.
Thank you for Drindrata MSMC and Dr. Go Suzuki for the enlightening and wonderful session. To all respected ladies and gentlemen, the next agenda is the second keynote session for today. This session will be delivered by Dr. Kengo Suzuki as a head of research and development, Euglena Company Limited, Japan, and it will be guided by Dr. Rernat Chandra Risdian as a head of bioprocess for cleaner production, research group from Research Center for Environmental and Clean Technology, National Research and Innovation Agency, Republic of Indonesia. Dr. Kengo Suzuki will deliver a presentation about research and development on the functionality and components derived from Euglena. If you have any questions during the sessions, please write down your questions in English in the chat box, because we will have question and answer right after each of the keynote sessions. And make sure that you write your name or simply raise your hand, and the chairpersons will give you the permission. To the Honorary Dr. Rernat Chandra Risdian, we cordially invite you to guide us as a chair for this session. Pardon, Sir Chandra, are you already here?
Yeah.
Okay, time and screen is
Thank
here.
you very much. Okay, thank you very much, Rizky. Good morning, everyone. I'm Dr. Chandra Risdian, the chair for this keynote session. Here we already have Dr. Kengo Suzuki as head of research and development, Euglena Limited Company, Japan. Dr. Kengo, are you already here?
I'm ready here.
Oh, okay. Yeah. Okay. Nice to see you. Thank you for joining. Thank you for joining us. Before we begin the talk, I would like to introduce you Dr. Kengo Suzuki's short bio. Dr. Kengo Suzuki currently works in Euglena Limited Company as a research and development company co-CEO. Euglena Company is a biotechnology company that researches, develops, produces, and markets microalgae. He received his PhD in the field of medical science from Kitasato University in 2019 and in agriculture from the University of Tokyo in 2016. His research interests mainly in the field of phycology, food science, molecular biology, and immunology. Currently, he is also appointed as visiting professor at the University of Gajah Mada or UGM. So now I would like to invite Dr. Kengo Suzuki, who will talk about research and development on the functionality of components derived from Euglena. We will have 30 minutes for the presentation and 10 minutes for discussion. Please, Dr. Kengo Suzuki, the time is yours now.
Can I share? Can I share my slide?
Yes, please, Dr. Suzuki.
Can you see with pointer?
Yes, clearly. Thank you.
Okay. I'm afraid I am now in business trip, so my Wi-Fi is little weak. So I am afraid that connection is disconnected. And hello everyone. Thank you for watching my presentation. And oh, sorry. Thank you, BRIN member, for giving me this chance. So far, I would like to introduce research and development on the functionality of components derived from Euglena in Indonesia. Firstly, let me introduce about myself. My name is Kengo Suzuki, co-founder and chief technology officer of Euglena Corporation Limited. I have an academic background in bioengineering, molecular biology, and immunology. Behind my picture is a trillion of Euglena cells, and I have been trying to use these creatures to solve various social problems. We have joint research with Gajah Mada University and BRIN. Next, I will introduce our company description. Euglena company has been for 17 years, and we have been making business with our philosophy, sustainability first. Sales in 2022 are expected to be 44 billion Japanese yen, or approximately over 5 trillion Indonesian rupiah. After 2026, we plan to expand our business to include biofuels. Since most of our sales are dependent on Japan, I personally would like to strengthen our expansion in Indonesia and other Southeast Asian countries in the future. This page shows the characteristic of microalgae Euglena. Length is about 15 micrometers, so you need microscope to see them. They grow by photosynthesis like plants and move around like animals. Because of having the both characteristic plant and animal, Euglena has a lot of nutrients. The number of nutrients is 59. By this characteristic, we make people healthy. And then microalgae euglena can generate lipid in the body. That lipid can utilize as feedstock of biofuel. We focused on the characteristic to advance biofuel business. By this characteristic, we make the earth healthy. Next, I will introduce our R&D history. The basis of euglena's current business model was not our own idea, but that of researchers in the past. In the 1990s, Professor Jiro Kondo of University of Tokyo, who also designed Japan's first passenger plane, proposed the use of euglena for food production and CO2 fixation. This professor was my own supervisor's supervisor, and I think it is safe to say that I am his grandson. Originally, Euglena Corporation Limited is a startup company from the Faculty of Agriculture of University Tokyo. We can succeed for the outdoor mass cultivation of the microalgae euglena for the first time in the world in December 2005. You can understand why my company's name is euglena, right? Initially, it was difficult to cultivate euglena on a large scale due to change in agitation conditions, which caused damage to the cell, and also due to the influence of microorganisms that invaded from outside. We tried things that could be verified on a small scale, such as growing euglena mixed with pond water. On a small scale as possible, minimize the need to culture on a large scale. But eventually, we were able to culture on a large scale. It was very difficult, but we did it. Now, this pyramid is called 5F of biomass and indicates value per weight of the market. For instance, food which is at the top of the pyramid, it is in special area, which means that food can get the highest value per weight as business, and then next to which can get high value in business is fiber, like bioplastic, feed, fertilizer, and finally fuel. Microalgae euglena can use as a stage of the pyramid. You can know easily that potential of euglena is really wide. Paramylon, a polysaccharide contained in euglena. This substance is very unique. And this substance, paramylon, could be used to create a resin that could be easily processed by heat. And the use of euglena-derived fertilizer has been found to promote the growth of komatsuna, one of Japanese leafy vegetables. Currently, we are continuing to test its effectiveness as a fertilizer on several crops in Japan and have begun marketing it. And let me talk about the ongoing fuel business. As for the research and development in Japan, validation of biofuel production has completed, including large-scale cultivating tests using exhaust gas from the thermal power plant. At the end of production process, the nitrogen is reduced from the culture medium. In doing so, effectively, Euglena stores carbohydrate in its own cell. Then, when the cells lack of oxygen, the carbohydrates are metabolized into lipid, and about 1/3 of the dry weight of the cells is made up of lipids. See the picture of them. With the support of Japanese trading company Itochu Corporation, we have tried small-scale cultures of Euglena in overseas. We are trying that in order to conduct a large-scale demonstration test in a place with favorable solar radiation conditions in the future. I would like to introduce the research we are conducting in cooperating with Gajah Mada University. We are searching for new Euglena species in Indonesia, and we are now conducting outdoor culture after lab culture, and we are getting good results. Next, I would like to report on our fuel supply structure and performance. This is our supply chain. We will use microalgae repeat and use cooking oil as a feedstock. Then we will produce renewable diesel, SAF, and biomassa as well. As for the diesel fuel we refined, named Susteo, the fuel we refined named Susteo, so we have supplied more than 50 customers with diesel, and the number is still growing. And we are also starting to supply jet fuel from 2021. Next, I will introduce our company description. And I believe that there is a potential to solve the problems of Indonesian and ASEAN countries with the technologies available in Japan. The idea is to improve the production of palm and to use unused non-oil components effectively to improve the environmental impact and increase the business potential. Also, the Indonesian diet is high in oil and sugar, which I assume is the cause of lifestyle-related diseases, and I am wondering if we can provide new functional food to help people stay healthy. This year, we have started a new project called Satoreps, which is funded by a Japanese government grant. The project will promote research on the use microalgae to absorb carbon dioxide and use it as a resource to solve problems in Indonesia. In this project, the CO2 fixation capacity of microalgae will be used to convert CO2 emitted from the coal-fired power plant and atmospheric CO2 into biomass. The effects of microalgae on the fermentation process are then utilized to produce value-added fermented food and fertilizer. This is image of microalgae-based carbon captured and utilization, CCU. Considered technology with microalgae to capture carbon dioxide and utilize it as sustainable resource is developed in Indonesia, which provides profitable scenarios towards carbon neutral society. And we were organized varieties of microalgae, including Euglena and Chlorella and Spirulina and others, as well as their merits and demerits regarding cultivation. Next, I want to introduce establishing a new Euglena species variety. This is Euglena project in Japan. This project is an ambitious effort to collect Euglena from all over Japan for collection. It will be a kind of citizen science. There are various types of Euglena, and we are focusing our research type called Euglena gracilis. Euglena gracilis grows faster than other Euglenoids and has been well researched, and its achieved ingredients have been extensively studied. And this project is an ambitious initiative to receive research funds and water that may contain Euglena from people living in Japan. I have promised to report back to the person who sent me the water and what kind of Euglena was there. Together with high school students in Yokohama, we collected Euglena and conducted a survey. And this is Indonesia case study. We collected pond and some river and some paddle field. And now 81 cells were isolated, and 12 strains grew up in PM medium. PM medium is Euglena's culture medium. And this is image of breeding improvement. Oil-rich strain Euglena is get from this cycle using heavy metal ion beam. And separation using a cell sorter requires setting condition to avoid cell breakage, and we optimize. Recently, cell sorters have been used to effectively select cells. And we were able to obtain strains that accumulate a lot of oil by irradiating them with heavy ion beams and selecting them. We have been able to obtain strains that contain more lipids than conventional Euglena under multiple conditions. And we have also collaborated in writing paper to contribute to the academic field. In 2016, I was co-author of a paper submitted to Nature Microbiology, and the result of this research were featured on the cover of the journal. review the operational of Uganda genome edited technology to contribute to the achievement of the SDGs. And let me share with my vision for the development of new materials that are expected to lead to prevention of disease in Asia. What I am focusing on is tempeh. Fermented foods have always been good for health, but soybeans are also a material with a low environmental impact, and I believe that there is a high potential for its high added value. Already in Indonesia, maybe all you know tempeh, a soybean traditionally issued in the diet, is widely used. On the other hand, the Uganda we work.
Excuse me, Dr. Suzuki, you have 4 minutes more. Only 4 minutes more. Thank you.
Sorry. This Uganda powder is added traditional Japanese rice pouch in production. It has been found to improve enzyme activity and increase the amount of ergotamine, which is attracting attention and antioxidant. And we get HAL certification. This is green tempeh production process. We are considering measuring the antioxidant and enzyme activities to see if we can do some test marketing in Indonesia and Japan. I'm looking forward to produce something delicious with the spirulina. I would like to try in my hand at producing blue tempeh. And finally, I will introduce our next challenge for going to space. Within the development of space, it is said that 1,000 people will be living on the surface of the moon by 2040. We hope to contribute to material circulation in the space with our technology. This is a conceptual diagrams of a system that use microalgae to produce food while regenerating water and gas. And we are also conducting research on the taste of Uganda and other algae. At first, I made and tried a 100% Uganda delivered hamburger steak without flour, eggs, and other mixtures. But it has a unique taste and that even I found difficult to finish. Now we are developing technology to make the food taste better using ingredients that can be easily produced in space with advice from cooking schools. We are now looking at culture in a flat panel with LEDs to increase productivity per volume. We are getting 0.5 gram dry weight of microalgae powder per liter. The result of this article will introduce you to create creature that may enrich our food space and food in space and contribute to the sustainability of oceans on the Earth. It is a type of microalgae called orangeoctylene, which makes DHA and astaxanthin. If this is made into a good taste, it can be used as an ingredient in sushi. Then we had space-related business worker and investors try the food. They found it to be very tasty. I am trying to think of ways to supply this material to the world as a healthy food that sustains the marine environment. We would like to work together with you to create sustainable society using microalgae. I represent all UGRENA members. I want to say thank you.
Okay,
I
thank
finish
you.
my
Thank you very
presentation.
much. Big applause for Dr. Kengo Suzuki. Thank you very much for your very nice presentation. And yes, now we are in the discussion session. There is already one question, one participant with two questions from Dr. Umi Hamidah. The first question for you is, what is the biggest challenge for Euglena cultivation? Is it resistant to zooplankton? This is the first question. And the second question is it possible to use wastewater as a growth medium of Euglena? So please, Dr. Kengo Suzuki, could you please answer those questions? Thank you.
Sorry, I catch up a question from chat field.
Yes.
I reply. First, most of this challenge is prevent other microorganism growth. I make culture medium pH decrease, more acid using sulfur substance and some organic acid. And CO2 percentage is high. Animal plankton is in high CO2 condition. Animal plankton is not alive. So growing CO2 very much. And other organism not to avoid euglena growth. And second, I want to use pome from palm plantation industry, and
Sorry, participants, for the technical problem. I think the problem is with Dr. Kengo Suzuki's network. Okay, please, Dr. Kengo Suzuki.
Sorry.
Yeah.
So sorry. Water. I use water. Recycle again and again.
Okay, thank you very much, Dr. Kengo Suzuki. The next question, I think, will be from Dr. Hanis Ambarsari. Dr. Hanis Ambarsari, are you here now? Yes,
Okay.
please.
Yeah. Thank you. Thank you for the time. Konnichiwa, Suzuki-san, Suzuki-sensei. Okay. Thank you very much for your nice presentation. It's very informative and inspiring. I just want to know where did you get the Euglena species that you developed? Is it from Japan or is it from Indonesia?
Both we use now. I bring some with some contract bring from Japan for Indonesia. That species has tolerance for high temperature and growth there because Indonesia's climate is higher, temperature is higher compared with Japan. So its tolerance is very important, we consider. And with Gajah University, we collected wild type of Euglena around Gajah University and Bogor or some area. And we selected higher growth and tolerance for high temperature.
So are you just focusing on that one specific species, Euglena gracilis? And you found that species in Indonesia also, or you will export another species in Indonesia, the same genus?
I consider now in Indonesia is hopeful species we get. So in Indonesia production, the species is most useful, and I want to cultivation area I expand to ASEAN. So some contract is need. We want to confirm some possibility to import live Euglena cells. And dried Euglena powder is not so difficult to making contract. So if Indonesia is profitable for making Euglena powder, we make Euglena powder more and more using Indonesia species and provide all over the world.
Okay, thank you very much.
Okay. Thank you, Dr. Hanis Ambarsari, and the answer from Dr. Kengo Suzuki. I think this is the last question because we have limited time. I'm so sorry. I will read the last question for you now. So this is from Professor Tarsan Sembiring. What is the essential nutrition from Euglena, Dr. Kengo Suzuki? What kind?
Euglena growth need this substance mainly light or carbon dioxide and nitrogen source is ammonia, ammonium is need, and some vitamin 1 and vitamin 12 is need for growth. And the trace element is also need, but so not so high amount. And I will produce culture medium easily in Indonesia, and growth Euglena and Euglena powder contain various nutrients for human. It is reasonable for Euglena food production system.
Maybe could you tell us about the nutrition from Euglena that benefit for the human?
Okay. Euglena contains unique polysaccharide paramylon. That substance contains 30% as carbon energy source. Paramylon made from beta-1,3 glucan. So beta-1,3 glucan control immune system. So this substance useful for prevent COVID-19 or some virus or microorganism disease.
Okay, so much benefit for us. Yeah, thank you very much for the answer, Dr. Kengo Suzuki. Now, I will summarize this session. Euglena is a microalgae that lives mainly in fresh water and can produce lipids. It can also be used as fuel, food, and other applications with a low environmental burden. Euglena company succeeded outdoor mass cultivation of Euglena for producing supplements and also food materials. They also developed a genome-edited strain stopping the paramylon synthesis and green koji, green tempeh, and also the space food. So before we close this session, I would like to invite Dr. Kengo Suzuki, because we will give the certificate of appreciation and have a photo session. For the committee, please give us a cue. Okay.
Okay.
Ready? One. Okay. 1, 2, 3. Okay. Thank you very much. So this is the end of the keynote session. Once again, thank you very much, Dr. Kengo Suzuki, for sharing, and also all participants. See you then. And I will give this back to MC, please, Mr. Rizky.
Yeah. Thank you, Dr. Renat Chandrarisdian and Dr. Kengo Suzuki for the enlightening session and wonderful presentation. To all respected ladies and gentlemen, the next agenda is break sessions in 5 minutes and then directly continue with the parallel oral sessions. There will be 4 parallel oral sessions, same like yesterday, that differentiated by each topic or term, and you can take it in the program book. And to the honorary oral speakers, you can join the breakout room from now or after the break. And please make sure that you are in the right room by checking the schedule. And to the honorary participants, you can choose and join the breakout room based on your interest. For your information, all the parallel oral sessions will start sharply at 10:40 a.m. until 12:10 p.m. and then directly continue with the lunch break until 1 p.m. We will meet again in this plenary main room for the next keynote sessions, for our last keynote sessions at 1 p.m. And for parallel oral sessions, we will give the session to each chair of each room. And good morning and have a good discussion.
Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born.
Yang menambahkan kemampuan si DNA-nya tuh untuk bertahan melawan si radikal-radikal bebas. Jadi namanya antioksidan. Jadi supaya si selnya itu tidak teroksidasi.
Okay, the breakout room is now officially opened. To the honorary speakers, you can join the breakout room from now. And please make sure that you are in the right room by checking the schedule. And other honorary participants, you can choose and join the breakout room based on your interests. And don't forget, we will meet again in this plenary in this main room at 1 p.m. for the last keynote session. Thank you. Good morning and have a good discussion.
Cek uangnya dicek. Guys.
Indonesia is the most beautiful land in the universe. The land where we were born, the nation where we grew up. So many colors that live together in peace. With a million timeless treasures, with an abundance of natural wealth. Indonesia is not just wonderful. Indonesia is a wonderland.
Kota baru gunungnya bermegah, bermegah, mana di Samangkara, mana di Samangkara. Batamu lawanlah adinda, adinda iman di dadara, sama layang iman di dadara, sama layang. Sayang, sayang si patokaan, makai go gorokan. Sayang, sayang, sayang si patokaan, makai go gorokan. Sayang, sajojo, you madam ko bisa berpare samuna keke, samuna keke. Soleram, anak yang manis, anak manis, janganlah dicium, sayang kalau dicium, merah pipinya. Kampunan jauh di mata, kunwangsan sebaku lilian, takkan aja kawan-kawanan lamu, sangke basuh yang surian.
Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born. Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Sekarang yang terjadi, terobosan itu menjadi mungkin oleh yang namanya, saya ulang, oleh yang namanya ilmu pengetahuan, oleh yang namanya teknologi, oleh yang namanya inovasi.
In 2020, Indonesia entered a new national development era. On this term, President Joko Widodo administration turned its focus on developing Indonesia's human capital and mastery of science and technology through Indonesia's national research priorities. The quality of a country's research and innovation is a national asset. As a key step, the government issued Law No. 11/2019 on the National System of Science and Technology, or the Sisnas-Iptek Law. By issuing the law, the government of Indonesia was signaling more attention to and commitment for the growth of the research and innovation during the next phase of Indonesia's development. 9 research fields are listed as the focus fields of Indonesia's 2017-2045 National Research Master Plan. Food, energy, health, transportation, engineered products, defense and security, maritime, social, humanities, and other research fields. These are expected to be able to produce innovative products. In order to address institutional problems of fragmentation among government institutions and the inefficiency of the budget allocation, the National Research and Innovation Agency, or BRIN, was established in 2019 with the Presidential Regulation No. 74 of 2019 on the National Research and Innovation Agency. The President has tasked BRIN to ensure that research and development activities in the country could attract more investments to its science and technology sectors, integrating research and innovation resources, creating and open a collaborative global standard research ecosystem, and creating the foundation of a strong and sustained research and innovation-based economy are three directions of BRIN. The contribution of research and innovation to produce a variety of solutions can resolve the challenges faced by the government, industry, and society.
Mulai ya? Mulai ya? We wish you a good break and good afternoon to all respected ladies and gentlemen. In these afternoon sessions, we will have one keynote sessions, parallel oral sessions, and also the closing sessions. The third keynote sessions for today will be delivered by Professor Imasiku Nyambe from University of Zambia, and it will be guided by Dr. Hanis Ambarsari as a principal researcher from Research Center for Environmental and Clean Technology, National Research and Innovation Agency, Republic of Indonesia. Professor Imasiku Nyambe will deliver a presentation about environmental impact of copper and lead mining to water, agricultural plants, and human health in Zambia. If you have any questions during the sessions, please write down your questions in the chat box with English. And because we will have a question and answer right after the keynote session, make sure that you write your name or simply raise your hand and the chairpersons will give you the permission. So the Honorary Dr. Hanis will cordially invite you to guide us as a chair for the sessions. Pardon, Madam Hanis, are you already here?
Yes, thank you, Mr. Rizky.
Okay, time and screen is yours.
Okay, thank you, Mr. Rizky. Assalamualaikum, peace be upon you all. Good day, ladies and gentlemen. I'm Hanis Ambarsari. I will moderate this last keynote speaker session. We will have one keynote speaker from Zambia, and he will give the presentation about 30 minutes, and we will have discussion about 5 to 10 minutes. Before starting, please mute your microphone. And if you have any questions, you can write your question in English in the chat box during the presentation, or also maybe you can click the raise hand button after the talk. Okay, now I would like to invite Professor Imasiku Nyambe from University of Zambia, Lusaka, Zambia, who will talk about environmental impact of copper and lead mining to water, agricultural plants, and human health in Zambia. Professor Nyambe, are you there?
Yes, thank you very much. I'm here.
Good day to you. Is it what time is it there?
9 minutes past 8 in the morning.
Okay.
9 minutes
okay,
past
good
8.
Morning to you. Good morning.
Good morning.
Okay.
Oh, good afternoon to you.
Oh, okay, thank you. Okay, please present the short CV of Professor Nyambe, the committee, please.
Okay, thank you very much. Let me share my screen. Cannot start screen share while other person.
The committee will share screen, Professor. The committee will share screen. Okay, I will read the short CV of Professor Nyambe.
But I didn't send you my presentation. You don't have my presentation. I have my presentation.
Oh, okay. Maybe after I read your short CV, you can share screen yourself. Okay.
Yes. So can I share now?
Yeah, his full name is Professor Imasiku Anayawa Nyambe. He is the Vice President of the Zambia Academy of Sciences and a full professor of geology in the Geology Department of the School of Mines and coordinator of the University of Zambia Integrated Water Resources Management Center, a center that he established in 2006. He has a PhD degree in Earth Sciences, especially in sedimentology, in 1993 from University of Ottawa, Ontario, Canada. He has an H index of 24 and published over 150 articles. Professor Nyambe also has recently been awarded the OR Tambo Africa Research Chair, Water Conservation in 2020 at University of Zambia. Okay, Professor Nyambe, time is yours. You have 30 minutes of presentation. You can share your screen yourself. Okay, please.
Okay, thank you. Is my screen visible?
Yes, it's clear.
Okay, let me go into the presentation mode. Okay, so as I hope everybody should. As already alluded to, I'll be giving a talk on the environmental impacts of mining. And the picture you see there is the SADC region, Southern Africa Development Community, where Zambia is located. I don't know if my cursor can be seen when I'm doing this. Okay, and of course, that's where Zambia is. And the green part is the copper, mainly copper and cobalt that we are mining right there on the copper belt. So for those who may not be aware where Zambia is, we are in the Southern Africa region of Africa. Of course. So the next thing is to look at the historical background of the environmental impact. And I'll go through this quite fast because I want to spend time talking about what we did. Yeah, so Zambia has been mining for the past 100 years. And of course, our health, our economy is dependent mainly on copper and cobalt mining. And the deposit is mainly copper and cobalt sulfide ores. So sulfide, meaning a lot of sulfur. But as you know, when mining started, everything was dependent or focused on policy making with no regard to the ecosystem health and biodiversity. And so this map here just shows you the Zambian copper belt and mainly the geology, which I hope there are some geologists in this symposium. And of course, we have three main types of ore bodies. The ironite ore bodies, which are almost sandstones. When you have them operated on, they will give you at least a color that is almost white and stuff like that. Then you have the photoarenite ore bodies and the ore shell. The ore shells are mostly green. And the picture also shows you that this Zambian copper belt is full of mines, and some of them quite large, and some of them are quite small. And you can see a number of towns: Kitwe, Kalulushi, Chingola, Chirabombwe, Luansha. All these areas, mining is taking place in Zambia. And the mining methods that we are talking about, which may have brought some of the problems that we are talking about, the ones that are given here, where you have room and pillar or sub-level stopping and cut and fill stopping. And we also have those underground. You can see underground here, some people, and also Changa open pit. We also have open pit mines, okay, where we are mining these things. So in short, we are opening a lot of ground in Zambia on the copper belt, okay, and meaning that we have a lot of overburden. And of course, Some of these operations have taken a long time, and therefore, with the advent of new technologies, some of the old tailings, they are being remined. And of course, from mining, we come to mineral dressing or processing these materials, the rock materials, the deposits. And this is just a cartoon to show you the various processing methods that we use. We have first ore crushing. After the ore is crushed, then we concentrate it in concentrators, and then we smelt it in smelters, and then we finally refine the ore in our refineries. And because of that, what you have here is the contribution of mining in Zambian perspective to the GDP. To just show you that initially it contributed about 35%, and now it is almost from 12 to 15% as a contribution from mining. Uh, 12-15% contribution to mining GDP, and the copper prices have also been changing, if you can see here. Okay, from 1900 when we started some mining somewhere there, you can see the copper prices have been changing, and now they are almost between 7,000 and between 7,000 and 900, 500 per ton since 2010 to 2022. Okay, and that history can be summarized as follows. Okay, so initially when we started mining, the mining companies were in private hands, and then the government took over. This was the nationalization of the government here. You can see government hands. And then thereafter, again, we privatized our mines. They are now in private sector. Okay, so those are the people who are doing the mining. So what I'm saying is, with these huge tons of copper and cobalt for almost 100 years of mining, a company which was owned by Zambia, that's ZSCM, had discharged waste and held a number of licenses to do its mining operations. These licenses, some still exist. So 7 licenses to operate domestic waste disposals, 8 licenses to transport tailings to tailing dumps, and very important, please note, to transport tailings to tailing dumps, 9 licenses to discharge tailing effluent into public streams. Okay, so you have those licenses to dispose those tailings in public streams. And what follows is that you have these huge tailings dumps, almost covering an area of 9,125 hectares. Okay, so this is a tailing dump. Okay, this picture here, which you see. And then you have 9 slag dumps. For example, this one which you see here is a slag dump, which consists of 40 million tons of slag, and it's occupying 279 hectares. And you can see from just naked eye that you can still see some copper sulfate stuff there. Okay, so you have 32 overburden dumps with 1,899 million tons, covering an area of 206,406 hectares. And also we have 21 waste rock dumps. Okay, so the total area that these wastes cover in Zambia on the copper belt is about 216,257 hectares. Okay, so that's a lot of land that is not being used but covered by these tailings dumps. And on the other hand, we also have what we call air pollution aspects. You can see some of these air pollutions that affected some of the houses in Mufulira, for example. You also had the air pollution coming out of the smelters, even though that has been closed. So there's some changes that have been seen. Some new smelters have been put in place, like the one you see here, to try to reduce the sulfur dioxide in the air. Okay, so then I come to the main part where I'm saying, what did we do? Okay, so starting from 2001 up to 2010, 2013, and in the late days, up to 2021, we've been studying these environmental impacts on the copper belt and in the Kawe, the lead Kawe area. So what did we do? Of course, this is the studied areas, as I have been explaining, and this is just a map of the areas where sampling took place. Okay, so what we have is large-scale mining in the Zambian copper belt. It commenced in the late 1920s. Therefore, to assess the possible environmental impacts of mining and the ore processing, the environmental geological surveying was carried out in this study up to 2010. Okay, so here you have the major mining towns. You can see Mufulira there, Kitwe, Chingola. Okay, so the first thing we did was to produce an environmental geochemical atlas of the central northern part of Zambian copper belt, which you can see here. And how did we do it? First, we had to go in the field, 3 kilometer by 3 kilometer square, and they had to obtain 1,262 compost samples of surface soil, 266 samples of subsurface soils, 337 samples of stream sediments, 120 samples of surface waters, and 282 samples of vegetation. And of course, we also had some special studies that we did to try to look at these environmental impacts in mining. For example, gaseous and dust emissions monitoring, we had to do that, okay? And then we used a method of sampling followed by Salminen, until 1988 from Finland. They have a geochemical mapping field manual. That's what we used. And of course, we did most of the analysis in the Czech laboratories in Europe. And of course, you can see how we did that. Okay, here we are showing soil sampling at the top horizon, 0 to 10 centimeters. Okay, and also we sampled. You can see me here sampling lower soil horizon, 80 to 90 centimeter depth. So we believed that as geologists, we believed that if we sample the top part of the soil, if there is more copper on the top side of the soil, then we may interpret it as coming from human activities. And if we sample lower soil horizon, 80 to 90 centimeters, and there is no copper, then of course it shows that definitely copper on the top soil is coming from human activities, because when you go down to 8 centimeters, there is nothing. But if you have something, then you will take it that that is natural. Okay, so we also did some soil profiling. We did the same in this small town called Kabwe, okay, where we sampled a number of things, groundwater, stuff like that, vegetation, stream channels, sediment streams. Okay, so we sampled that in Kabwe as well. Of course, we also sampled the vegetation. You can see the photos. Okay. We also continued to look at the vegetation, the roots, checking those and trying to find out if we can be able to get some of the grasses that we can use to replant on the areas that are contaminated. The results, what are the sources of atmospheric contamination? Okay, so we had gaseous and solid emission from smelters, dust from dry parts of the tailing impoundments themselves, dust from mining operations, processing plants and slag depots, and of course, transport of concentrate and products. And on surface waters and stream sediments, we had the industrial waste discharged into the water courses, seepage and overflow from tailing impoundments, and of course, a lot of erosion that was taking place during that time, and even now. And of course, I've already shown you this as from the air pollution. We also had that effect. And you can see, for example, when we now analyze some of these, we found out that it contained a number of fine-grained airborne particles from the Kana smelters, slag particles. You have bonite. You can see BN there is bonite. And when we analyze these, we discover that the particles contain arsenic, beryllium, cobalt, chromium, copper, mercury, molybdenum, selenium, vanadium, and zinc. So that's what we found out. And when we come to the air pollution side, we had women assisting us to take some of the instruments that we had, okay, to sample the air within buildings, in schools, and at the mining itself. Like here, we're looking at Mopane. And what you see here are some of the results that we found out. And here, you can see for yourself that, for example, the red there shows that that is copper, and then the green is the lead, and the small part there, which is cobalt. And the other side, on the left picture, you see sulfate. And so you can see that even in in homes and the schools, some of the values of the lead were elevated. And of course, I've also talked about tailing dams. This is one example of a tailing dam. And you see, because of the wind, airborne particles from dry beaches of tailing impoundments are of course blown by the wind. You can see here a sandstorm, okay, or here. And some of these, when we analyze them, we found out that they contain a lot of arsenic, about 9,350 ppm of copper, cobalt, selenium, and stuff like that. And of course, some of the sources were from the technological waters, from mines, smelters, and chemical leaching plants, as you can see here. And the white which you see here, this is liming from the mining company, okay? And also when we go to the old tailing dams, these are old tailings dams covered by grass, but they produce iron hydroxide precipitate occurs. And some of these, when he picked them and analyzed them, they contain a number of these heavy metals. You can see for yourself for copper, 0.257% copper, 0.035 arsenic. So it's like every ground contains some of these heavy metals. And of course, this is the siltation that I talked about. You can see various siltations, and all these will end up in water courses. Some of them you have in here. For example, this one here, you see Kasue River, and this is where the Chingola water plant for drinking water is being pumped from this Kasue River side here. And of course, then we had now to look at each metal, and the examples I'm going to give here is just for arsenic and copper and cobalt. Okay, here, what you notice is that for arsenic, okay, on the left side, in the subsurface soils, you can see the reddish part is the high contamination, okay? And here in the subsoil, you can see that they are not the same. In the subsoil, you will find out that arsenic is not related to the mining activities. Like here, there is no mining, okay? And when you now compare it, that's arsenic in soils, you want to compare it to the geology, to where these deposit ores are, okay? So what you see here is that the lower part, okay, the red parts here that you see there, this is where the lower one containing ore deposits, copper deposits. And here on the left side, what you see is arsenic, and you are trying to relate it to see if the arsenic came from the deposit or from human activities. See for yourself, in this case, that's arsenic, and you can see that there's no ore here. Why high arsenic values here, for example? Okay. Okay, and here, when you look at this photo also, you see that there is no ore here. Okay, this is basement material, rock and stuff like that. But you have, in this area here, you have high arsenic. Where is it coming from? Okay, the answer is it's the road system, because you have roads here where the companies are transporting the ore from one place to other. Okay, and from that ore which you transport, some of it it's falling out from a truck, and it creates these arsenic levels here. So which means that the arsenic is coming from some of these human activities, from the overburden. For cobalt, you find the same thing for cobalt, but you find high values are related to these big mining towns. Okay. This is what I'm trying to explain in those diagrams. And then finally, we came up with a coefficient of industrial pollution to try to put these things together. And below here shows you the formula for that, where we have arsenic, cobalt, copper, mercury, lead, and zinc combined. And this will give us, if we plot it, will give us which areas are being polluted. And you can see on this map that where there are mining areas, that's Mufulira town, Kitwe town, Chingola town, you also have high values of, in this case, of industrial pollution. And of course, those arrows that you see in blue indicate the wind direction. You can see at the top there, the wind direction. So it means that the wind had also an influence in directing some of these contaminants in these areas. Then we move on to the crops. What about crops? So we had to sample the crops as well, because this is what people eat. And for example, this is cassava. I don't know if in Indonesia people eat cassava. This is cassava plant. And of course, we had to sample the cassava leaves, the roots, and the stems. And these data that you see, I'm sorry, you cannot read them, but those are the results. For example, what we got is that you see that copper, 11.7, 6.5 ppm, and arsenic, 0.43 to 0.8 ppm in the leaves, for example, they were quite high.
Excuse me, Professor Yame. Excuse me, you have 2 minutes left.
Oh, okay.
Yeah, around 2 minutes left. Please.
Okay.
Please.
Okay, then these others I'll move fast. I won't say that. This is the metals in the plants also. Okay, for the metals in the plants, you can see these are also associated with arsenic and the copper. So I'll move fast. And when you compare with the industrial pollution from the stream sediments, you can see that most of the streams were also affected, together with the streams from Chambishi and stuff like that. And of course, you can see that here, the copper in the Kafue and the cobalt, they are quite high when you compare to the European limit. Okay, and of course, these tailings, you find them there. Of course, I'll jump these. I just want to show you the Kabwe thing. I'll jump that because it's similar to the Kabwe thing. You can see that you also had the high levels of lead in Kabwe. And of course, I just wanted to go to lead because lead is very important, okay, in terms of its effects on human beings. And here you can see that the lead levels are quite high, okay. I'll jump this on the vegetation. and then come to the conclusion. In the scoping study that we did with our group, the lead levels in the blood lead levels were quite high, okay, for the children, medical children between the ages 0 to 7 years are the most vulnerable to these lead levels. And we did discover that we had to take children to be tested for these lead levels. And this is what I'm talking about. You can see that the lead levels are actually higher than 10 here. All these places here, they were high lead levels. So we recruited children to be monitored. And in the study that we did with the Kampai, this is the Kampai study, I'm concluding now. The Kampai study, we discovered that if we work on these things up to 99%, we can reduce this lead by covering the source areas and also putting in soil, uncontaminated soil in the cabo areas. Okay. We also did some cost benefits, how Zambia can reduce that for the lead. Okay, and these are the cost benefits. I'm sorry for that. Let me conclude. Here, you can see that we also advise the government that they could use this cabo area and divide it in areas that can be useful. For example, here you can demarcate it in industrial areas, commercial areas, residential areas, and agricultural areas, following, for example, the Canadian system of soil quality guidelines. Okay, so, and of course, it's important to also communicate to the people, to the public, and let them know, and encourage set up by government and policymakers. Okay, so of course, those are the problems. I end there. Thank you very much.
Thank you very much, Professor Nyambe. Please give a big applause for him. Okay, now we have two questions for question and answer session. We have a question in the chat room. I will read it for you. The first one is from Professor Tarsan Sembiring. He asked about the people health in the mining area and the cities in Gambia. What about the people health around the mining area?
The people what?
Health condition.
Oh, heart conditions.
Yes.
On the copper belt, I would say there are no studies that shows that the heart conditions of people on the copper belt have been affected by this copper mining and the tailings that I'm talking about. In the cabo area, the most people that we are worried are affected are the children, their brain, their IQ. Okay, so those things are the things that we think have affected the children in particular.
Okay, thank you. The second one from Mr. Rizky. Okay, we saw that from the slide that Zambia is a landlocked country. Is there any difficulties found in managing the environmental impacts of mining activity? Is there any policies for these rivers and lakes that transboundary river between countries? And also for the transportation, is it for domestic consumption or being exported?
Copper is mainly exported, particularly at the moment. I think Asia is the main market, particularly China. Of course, there are some that goes to Europe and America. So that's the export. That is the export routes for Zambia. On the copper belt, this copper belt that I'm talking about is the same copper belt that goes to Zaire or Congo. In fact, it's called the Central African Copper Belt. And if you know something about Central Africa, Congo is actually produces more copper than Zambia. It produces more cobalt than Zambia. And therefore, it covers both Congo and Zambia. So any effect that we have is covering these two countries.
Okay. Okay, the last one is about from Mr. Nixon, I think. Yeah, the last one, the last question. How about the concentration of copper?
Concentration of copper?
Yeah, what is the concentration found in the slag on the subsurface soils and the groundwater nearby tailing dam area?
Yeah, all these are that is what I was trying to show in my presentation. Okay, in my presentation, I was trying to show the concentration of the copper, cobalt, lead, and the other heavy metals in the tailings dumps. Okay, the tailings dumps themselves, in the subsurface soil and the topsoil. Okay, that's what I was trying to show. Maybe what I can do is we can share this presentation with Edward Nixon. We can share this presentation with Edward Nixon.
Yes, yes, we will.
So that they can read for themselves. Mm-hmm.
Thank you very much. Okay, now I will summarize about this session. I will summarize. I will read my summary. Okay, mining has been on in the Zambia for about 100 years, mining activities, but there are also negative impacts to the environment and the ecosystem, resulting in chemical pollution of water resources and agricultural plants. For example, cobalt, copper, manganese, selenium, calcium, magnesium, as well as cadmium, nickel, zinc, lead, also mercury, sulfur, etc. Mining processing facilities produce tailings that feed into tailing impoundment, providing dust fallout on dry section of the impoundment areas, affecting the plant life, whereas their dams are leaking and discharging a pulp rich in iron and other heavy metals. In agricultural plants, high concentration in roots and leaves has been noted in cassava roots and leaves, growing mainly near the smelter plants and tailing impoundments for both arsenic and copper, as well as mercury, sulfur, zinc, etc. So consumption of food that grow up in the polluted sites can be a health risk to humans. In conclusion and in combination, there should be application of soil amendments to immobilize lead, copper, and arsenic in the soil, such as compost, animal manure, biochar, and phosphate fertilizer before planting, and also to mix in the topsoil to reduce the lead, copper, and arsenic levels in the edible plants parts and improve the crop growth. Thorough washing of vegetable before cooking has been shown to significantly reduce the concentration in cooked food as a simple and very effective practice that also promotes the general hygiene. Therefore, monitoring, maintaining the standards and public awareness are strongly recommended, as government is still finding a way of dealing with these environmental issues by doing the remediation project. Okay, that's the summary of Professor Nyambe presentation. This session. Before we close the session, I would like to invite Professor Nyambe to have a photo session. Please adjust your camera, Professor.
Okay, let me see.
Yeah, so we can see the whole.
I just. Oh, okay. Where is that?
The camera in front of. Okay, maybe you can sit back, yeah, a little bit. Okay, we will have the photo session as well as the. We will give the certificate of appreciation. Please, the committee give us a cue. Okay, this one is the certificate of appreciation for Professor Nyambe.
You see me now?
Is it done? Is it done? The photo session, is it done? The committee, please.
Okay.
Okay, okay. Thank you very much, Professor Nyambe.
Thank you.
Okay, please give a big applause for Professor Nyambe for his informative presentation today. Maybe next time, I hope I can visit Zambia, maybe. Next time.
Yeah,
Okay.
and maybe
Thank you
next
very
time I
much.
will also be given more time.
And please come to Indonesia later,
Yes.
Professor. So this is the end of the last speaker session. Thank you very much.
Already in Bandung.
Okay,
Please
I'm
come to
leaving the
Bandung and
meeting
to
now.
Jakarta.
Okay,
I'm
I'm leaving the
apologizing
meeting
for
now.
any inconvenience. Yeah. Thank you very
Yeah.
much. See you then.
Chair, I'm leaving the meeting now.
And I will give back to the MC. See you, Professor Nyambe. Pardon me?
Okay.
Okay, I give back to MC. Thank you, Mr. Rizky.
Thank you. Thank you. Thank you. Thank you, Professor Imasiko Nyambe, for wonderful presentations, and Dr. Hanis for all the enlightening sessions for the keynote. And to all respected ladies and gentlemen, before we continue to the next sessions, we will have a quiz. We have a voucher for 3 winners. So same like yesterday, the quiz will be performed through kahoot.it platform. First, you can enter the platform by type your kahoot.it, preferably in your other devices than your laptop or handphone that you use to this Zoom, and enter the code type on the screen later. We keep the code type until you're ready, and type your real name. Is it important? Type your real name so we can easily contact you if you become a winner. For your information, the 3 winners from yesterday quiz did not contact us until today. So if one of you become the 3 winners from yesterday's quiz, you can easily contact me or the co-host or the host of this Zoom, the Hidayat, or co-host number 2. Okay, is the platform ready?
What is the game pin?
Wait, Dr. Hanis, wait. Okay, it's already on the screen. The type code is 7 digits of number. You can type. We will wait until 2 minutes, no more and no less. We go to the quiz. Okay, there are how many persons? Okay, I think about around almost 20s, right? 20s, okay. It's still coming. Okay, come and join us. It's the second quiz. We have a third quiz before the closing session, so I recommend you to use your real name. Okay, 1 minute more. Okay, 1 minute more. We still wait for 1 minute more for all participants, or you can join this quiz. Begitu sulit. Who is she or he? Begitu sulit. Toby. Iya. Insan, Randy, oke, Resio, oke, Astrid, Nilawati, Hani, oke. I think almost 40 participants in the quiz. Okay. Is the platform ready for the questions? Huh? Oke, siap ya. Oke. Oke, I will count until 1. So 5, 4, 3, 2, 1. Okay, we go with the quiz. Starts from right now. Okay. Wait.
Oh, whoa.
Yeah, you have a clue for the first question, so you can Oh, it's only 3.
Ya iya kan? Ya dia keluar dia tahu.
Okay.
Riset.
Yeah, sorry. We are sorry for the inconvenience. We repeat again the first questions, okay? So it is very easy for you. The first questions, all the participants should be answered correctly because we are sorry for the inconvenience for the technical problems.
Kenapa sih? Tadi tuh kenapa sih?
Nggak tahu. Sorry, pardon for the inconvenience. We had the new links and new pins for the Kahoot IT. It's already written in the text box and the chat box. And our team still constructing the Kahoot answer and questions. So go to the kahoot.it. It is the game pin written in the chat box. We had a new pin and new links actually. Okay, our co-host. Okay, we will wait for 1 minute. Yeah, 1 minute. 1 minute again. Shulit. Where is he? Who is he? Who is he? Shulit. Oh. Saya. Who is he?
Saya Suzuki.
Oh, 43% and still increase. 30 seconds left. Mundur. Okay, so I will count until 1, 5, 4, 3, 2, 1. Okay, 46 participants. The game starts right now. All the participants must answer correctly. are 5% still wrong. 5% wrong. Okay. We see the positions standing after the first question. Okay. With the Madam Neni, Miss Neni. Okay, we go move to the second question. If you join us in the morning, you will know the answer. Yes. So okay, there's a changing in the first position, right side of number 1. There's some. Okay, third question. Hey, you must answer correctly. Please. 5% still wrong. Okay, Raisa is still number 1. Shulid, which is Shulid? Okay, question number 4. It is the one of the keynote speakers in the morning session. Okay, we see. Raisa. Raisa is still number 1. Okay, it is one of our keynote speakers yesterday. Okay, who is the third winner? Saya. Who is he or who is she? Let's contact us. Contact the co-host, also contact the host. Eva is not the second. Nela. Oh, where is Raisa? Okay, the three winners. You can contact us. You can contact me or contact Hidayat as a co-host or another host. Because you will get the prize. So it's important that you contact us. Okay, it's enough for the quiz. And thank you for your all participations in the quiz. Thanks for the active participation. We have the last quiz before the closing session. So you make sure that you will attend this symposium until end. For those who have not won yet, we will have another quiz. Okay. And to our respected ladies and gentlemen, the next agenda is the parallel oral sessions. In this afternoon sessions, we will have 2 sessions of each parallel oral sessions. There are 4 and 2 parallel oral sessions that differentiated by topic or term. You can check it in the program book. In the first sessions, there are 4 rooms, and in the second set, there are only 2 rooms. And to the honorary oral speakers, you can join the breakout room directly after I give the session to each chair. And please make sure that you are in the right room by checking your schedule in the program book. And to the honorary participants, you can choose and join the breakout room based on your interest. And for your information, the first sessions of parallel oral sessions will start at 2 p.m. Yeah, more or less 2 p.m. until 3:30 p.m. And the second session will start at 3:40 p.m. until around 5 p.m. We will meet again in the plenary for the quiz and the closing sessions, and also the best announcement of the best presenters at around 5 p.m. And also we have the photo sessions together. And for parallel oral sessions, we will give the session to each chair of each room. Good afternoon and have a good discussion.
Cek.